Okay, this is text section 7.1, and this is the law of sines, and we're dealing with non-right triangles, okay? And in this case, we're dealing with oblique triangles almost every single time. Okay, the law of sines is used in a couple of cases. Before we get to that, just a reminder that capital letters are your angles, okay? So let me get my pen here. So capital letters are your angles, and then lowercase letters are your sides, okay? And then make sure your your calculator is in degree mode, okay? Make sure of that, that'll really help. The law of sines is 3 pairs of ratios. It's A over the sine of A equaling side B over the sine of B equaling C over the sine of C. And you'll just do cross multiply and divide. I won't even do the calculations because it's something that you should know how to do. And the law of sines is going to be used when you have two things, angle side angle or side side angle. The side side angle one is the ambiguous case where you may have two answers, you may have one answer, you may have no answers. That is a separate video. That's page 2 of your lesson. Well, that's going to be a separate video. So this is page 1 only, where we don't deal with the ambiguous case, okay? All right, so I'll draw these out. It'll take me it takes a lot of room here, but I'll try to draw as best I can to scale. So, all right, so the first one, we got side, let's see here, something like this. This is 44 degrees, so I'll label that B, so you can have it all labeled. And you should take the time to label it all. This is 57 degrees. I'll try to be close on the degrees and angles. It won't be perfect. And A is in between. Reminder that the angles and the sides are opposite in their labeling. So this is going to be angle A. Well, clearly, when you have two angles, you have the third just by the 180 rule. So that's going to be 79 degrees. So that's 79. And now I'm all set up, okay, because I have a pair of angles. I mean, not a pair of angles. I have a pair of letters, A and A. I need that, okay, for the ratios, okay. So it's going to be A, which is 4.7 over the sine of 79 degrees is going to equal, I'll go ahead and set both of them up, okay. It's going to equal B over the sine of 44 degrees. And that's going to equal C over the sine of 57 degrees. Okay, and then again, you'll do your cross multiplying, dividing. And you can check your answers. You can stop the video if you need to. B is 3.326, and then C is 4.016. Okay, so that's 1A. There's 6 of them here. Probably a little overkill, but that's all right. Okay, so B then, slide this up just a little bit. Okay, so B, circle the one we're working on here. Let me draw this one out. So this is 29 degrees, pretty thin angle. And we got almost a right angle here. I probably drew that a little too big, but that's 88 degrees. Okay. And then C is 11.4. Okay. So this is 11.4. Okay. So I have two angles, so I certainly have the third. Whenever you have two angles, you automatically have the third. It's that SSA case where you have an angle, but it's not in between the two sides that becomes the problem. Okay, that's a totally separate issue. Okay, and really the law of sines and the law of cosines really work in harmony with each other. And I'm going to pause for a minute and try to explain all that to you. Okay, in the middle of the video here. All right. So I'm going to go ahead and get B. B is 63 degrees right here. That's pretty easy to get just by going the 180 rule. And now my ratios are all set up. I have 3 angles, no problem. I'm going to set these up pretty easily. Okay. So we got, let's see, I have C, so I'm going to go 11.4 over the sine of 88 degrees. Okay. 11.4 over the sine of 88 degrees equals A over the sine of 29 degrees equals side B over the sine of 63 degrees. And again, just do them one by one, cross multiply, and then divide. Okay. And then A comes out 5.53, and then B comes out 10.164. Okay. 5.53 and 10.164. Okay. So let's go to C. Okay. And then C, to get a good drawing, I'll put the drawing right below it, I guess, in this case. So we got 92 degrees. This is 92 degrees. All right. Sounds good. And here's 41 degrees. It's a decent drawing. And then, so we got 92, that's A. B is 41. And then they tell you B, which is opposite, is 5.5. Okay. But we have 2 angles, so we certainly have a third. So the third angle is 47 degrees. That's pretty easy to find. Okay. Now we're going to set up our ratios. Okay. The ratios. So we have, we got side B, which is 5.5 over the sine of 41 degrees equals A over the sine of 92 degrees equals C over the sine of 47 degrees. All right. And when you're done doing the math, A is 8.378. And then C is 6.131. Okay. Absolutely awesome. All right. So the next 3 are going to be similar. Let me slide them up here. Okay, the next 3 are very, very similar, but I'll go ahead and run through them anyways. If you, so this is D right here. Great. So D, we got A is 54 degrees, and I put that down here. Just a little bigger than a 45. And then C is 63. That's a little bigger than that. So I'm trying to draw it realistic, but it's not perfect, obviously. Okay. And then they tell you that tell you B is 9.2. So I got angle, side angle. Okay. So, and again, once you have 2 angles, you got a third. That's pretty clear. By the way, the law of sines is easier than the law of cosines, which you'll learn later. So you really want to try to do the law of sines when you can, and we'll talk about the difference in subsequent videos of when you do what. All right, so once you get that, angle B is pretty easy to get. That's over here. That's going to be 63 degrees just by doing the 180 rule. All right, so now we can go 9.2 over the sine of 63 degrees. Make sure you're in degree mode. Equals A over the sine of 54 degrees equals C, side C, over the sine of 63 degrees, okay? And then when you're done, A comes out 8.353, and then C comes out 9.2. Okay? All right. The last two, I'm going to skip. I'm just going to put the answers down because I think at this point in the video, to make it a little shorter, you probably have it dialed in before I go to the word problems. And if you need further clarification, we can do those in class. But for E, C is 40. A is 15.065. And then B is 15.852. Okay, the last one is 63 degrees. A is 6.568. And then C is 4.228. So check those for the last two for E and F. That's E and that's F. If you struggle on those, we can do those in class. Now we're going to do the application. Some of these problems are extremely difficult. Not difficult, they're just tedious. So let's give them a shot here, okay, for these. All right. So let me go ahead and move this up a little bit. All right. So I'm going to make this even bigger so I have more room. Okay. All right. So question A, the Leaning Tower of Westminster, I'm sure you've heard of that, leans 3 degrees from the vertical. An observer standing 50 feet from the tower, away from the leaning, has an angle of elevation of 47 degrees to the top of the height. Find the tower, no problem. So we got some different things going on here, some different skills. First of all, let me draw the tower. Okay. So the tower itself is going to be this beautiful structure. Look at this thing. Wow, this is amazing. There's my leaning tower of, well, I should make it leaning since it's called the Leaning Tower of Westminster. That would make a lot of sense. Okay, so I'm going to have it leaning slightly. How about that? Perfect. Okay, so it's 3 degrees from the vertical. So I'm going to make me this. There we go. This is 93 degrees because it's leaning 3 degrees from vertical, which is 90. All right, fine. And they said there's the angle of elevation was 47 degrees. That's right there, 47 degrees. Awesome. Okay. Then it says observer standing 50 feet from it. So this is 50 right here. All right. Notice I have angle, side, angle. I have angle, side, angle. So I'm going to be able to use the law of sines. No problem. It's great. Okay. So this is 40 degrees in case you wanted to know, and you're going to want to know using the 180 rule. So eventually, I'm going to try to find out the height of the tower. I'm going to call this, well, I'm just going to call this X for right now. X. We don't really have A, B, and C right here. Call that X. All right, so I know that X over the sine of 47 degrees is going to equal 50 over the sine of 40 degrees. Okay, I'm going to solve that. Pretty simple. Okay, you have angle, side, angle. We don't have a right triangle, so we can't use the Pythagorean theorem, so we can use the law of sines. Okay, so go ahead and solve that. You're going to get 56.889. Okay, go ahead and pause that if you need to draw it. Okay, question 2B. Now 2B, we're going to get into bearings, which is a review from earlier in the course. Okay, a ship sails 260 miles from port A to B at a bearing of south 38 degrees west. Okay, first thing we got to do is remember our degrees. Okay, I'll put it right here. So we got north and south. Okay, so if you got north and south, This will be west and this will be east. Okay. So that's the first thing you got to remember, which you may struggle right there. Okay, from there, it sails at a bearing of 55 degrees east to port C, which is due south of A. How far apart of the, all right, wow. A lot of drawings here. So let me get a good one in here. Okay, so we got A. I'll put a little circle around that. And C is due south. So I'm going to get that already in play because it says there due south. That's kind of nice to know. They want to know how far apart these two are. Okay, so what I really want is this right here. I want X or whatever we want to call that. Okay, that's what I want to know. So first thing is I'm going to go to B first. So south 38 degrees west is an opening right about here where this is 38 degrees. Okay, because remember the bearing points south, which I am pointed south. There's the arrow. And then I'm going to open up 38 degrees west. Okay. And then B is somewhere down here. I'll throw it like right here. Again, I'm trying to draw to scale. It may not be perfect. Then from there, it goes south 55 degrees east to port C. All right. So I'm going to, sometimes you draw crosshairs if you want to. So I'm going to go south. Okay. And then 55 degrees to C. So what we got here is this angle right here is 55 degrees. Okay. All right. So I got to get some angles here. The first thing you can kind of figure out if this is 38, so is this because of alternate interior angles. Okay. Now that makes this angle right here, and I'm going to change colors here just to help you out a little bit. That makes this angle here 87 degrees. And how I got that is going 180 minus the summation of 38 and 55 because this is a line right here. That's tricky just to get to that point, okay? And then that makes this one 55 degrees for a couple of reasons. That's again alternate interior angles as well. Okay. Really, the bet you could have done it that way, or you could have said this is 55, so that's 55, so then that's 88. It's the same thing. Okay. So I got my triangle. Okay. Now that I got my triangle, I'm looking for distance X. Okay. So I'm going to do the I'm going to do X over the sine of 87 degrees, and that's going to equal the by the way, I forgot to put 260. This was 260 from A to B, 260 right here. There we go. There's the missing piece. Equals 260 over the sine of 55 degrees. So I got my ratio. Okay. These are kind of easier than the ones above because I'm only asking for one answer, not three. But a lot of work there. Pretty cool. So pause that if you need to. And again, the keys here is we know this is 55 and this is 55 because of alternate interior angles. I did it another way as well. I went 38 and 38 and then figured out this one too, but it's the same idea either way. Okay, very cool problem. All right. Let's go to C. Okay. Let's see here. So here's C. Two planes are descending at different altitudes towards a landing strip that are 2,000 feet apart. Okay. From a flight tower. All right. So let me draw the tower. Let me get this nice and low. The tower is on the ground, I suppose you could look at it that way. There's your flight tower. Okay. From the flight tower, the angle between the two planes is 31 degrees. All right, so I'm just going to try to draw this. that look about 31 degrees? I suppose. Okay, 31 degrees, less than a 45, all right. And its distance to the closer and lower plane is 850. So I'm going to put this as 850. This is feet, I guess. That seems awful close. Okay, but it's okay. So there is plane one, I guess. This is plane one right here. Okay. All right. And see, the planes themselves are 2,000 feet apart. So this is 2,000 feet. Again, those seem really close. This is plane two. Okay, so I got a lot going on there. So let me try to get a different color in here to help you out. Plane one is here. This is plane two is there, that dot. Okay, so we got some of the key numbers here. All right, fine. Once you have this drawn, you're going to be okay, I think. How far is the flight tower from the other plane? Okay. Okay, let's check it out. Okay, now this problem is very involved. Okay, so it's going to be really difficult. A lot of steps here. So I'm not expecting too many people to get this. You're just doing it for the first time. You got a situation here where you need to get the other two angles. The angle that we really need right here is this one right here. We need that angle because we're going after this right here. Okay, but I don't have the setup to do that. So what I'm going to do is I'm going to do the first step. Step one is going to be, I'm going to call this step one. Step one, I'm going to set up this ratio, 2,000 over the sine of 31 degrees. Notice those are opposites. Okay, 31 degrees equals 850, okay, over the sine, and I'm going to call this B for lack of a term there for sine of B, okay. Now, when you do this, you're going to have to do an inverse. So I'm going to go over to my calculator and go ahead and do this, okay, so you see it. All right. So here's the calculator, and works out perfect. You can set it, see it there. So I'm going to go 850, make sure you're in degree mode, times the sine of 31 degrees. Okay, hit enter. I'm going to divide that by 2,000. Okay, now you get a decimal. What that means is, and I'm going to go back to writing on the screen here. What that means is we got the sine of B equaling this decimal point, 21889. Okay, I'm going to do the inverse of this. So I'm going to go second sine of the answer, okay, which is down here, second sine of the answer, close parentheses. And it's going to give me the degrees. It's about 12.6. But I'm going to just label that as 13 degrees, about 12.6, okay? So let me go back, let me lower this. So it ends up, you get about, angle B is about 13 degrees, which is right here. So that's 13 degrees. All right, now I can finally get this angle, the one I want. I'll change colors again so you can see that. I'm going to use the 180 rule. So step two, I'll put it down here. I'm going to go 180 minus the summation of 31 plus 13. And the angle right here that I really need, because I need the one opposite the side I'm looking for. 31 plus 13, that angle ends up being about 136 degrees. Awesome. That is 136. Finally, I can get what I'm looking for X. X over the sine of 136 degrees equals 2,000, the other one that I have, over the sine of 31 degrees. Okay, that is finally the ratio that I need. And the answer is about, depending on how you round in the beginning here, about 2,680. Okay, somewhere in there. Wow. It's a very cool problem. Very challenging, especially day one of learning something new. Okay. So again, lots of writing there, a lot of chaos there, but that's the cool part about math. I love that stuff. All right, D, the last one here. So D, a surveyor standing away from a building notes that the distance and angle of elevation to the top of the building is 438 feet at 44 degrees. He notes that the angle of elevation to the top of the flagpole atop the building is 48 degrees, the length of the flagpole. All right, the power of your drawing again. So let's draw this out, okay? So you got, let me try to draw it to scale if I can. So here's my building right here, okay? How about the buildings right there? And I'm gonna make this, this is 44 degrees it said. So it's almost a 45, 45, 90 triangle, meaning the shadow is the same as the height of the building, so to speak. And it told me this distance was 438. That distance, okay, feet, I guess. Okay, and there's a flagpole up here, so I'm gonna change colors and draw me a flagpole. There's a flagpole right there. How about that? Okay, and that flagpole, the angle of elevation to there, so this right here, I'll put an arrow there, is 48 degrees, meaning the little teeny angle there is 4 degrees. Okay. All right, now they want the length of the flagpole. Okay, so we got a little bit of work to do, a little bit of critical thinking to do. Again, different color. So this is a 90 on a regular building. This is 44, so that makes this right here 46 degrees. Okay, make 180. That makes this right here 134 degrees. I got that because I'm assuming the flagpole's at a vertical, and then it'll make a 180 degree angle, a straight line on that, okay? Which should make this angle right here 42 degrees, wow. So let me just redraw the what we're looking at, what we're looking at. Okay, something like this, right? So this is 134. This is 4 degrees. And this is 42 degrees. Did a lot of stuff with the 180 rule in mind. Okay. And I got this right here at 438 feet. Okay, change colors. I'm looking for X right there. That's the height of the flagpole. So I cut the building out and just did that part. Again, a lot of thinking, critical thinking just to get there. Okay. So what we're going to do next is we're going to set up our ratios. So the ratios that I got are 438 over the sine of 42 degrees. This side is opposite that angle. It's hard to see it because it's an obtuse triangle. That's going to equal X, which is the height of the flagpole, over the sine of 4 degrees. Makes sense. The flagpole is probably the shortest thing, and it'll be opposite the shortest angle. Just to get to that point takes a lot of work. Okay. Then once you go ahead and solve it, the flagpole is 45.661 feet in height. Okay. That is chapter 7.1, day 1, the law of signs, but not the ambiguous case quite yet. All right. Thank you so much.